Okay, combinations of transformations. So the transformation of a sine or cosine function has the general form y equals a sine k x minus d plus c, or y equals a cos k x minus d plus c. Remember that whenever you are looking at a transformed sine or cosine function, the coefficient here of the variable x has to be factored out. So remember to factor out the k value. So the values that we have here in the expression, the value of a tells you the amplitude. The value of d tells you the phase shift, so how much you're shifting the graph left or right. The value of c is a vertical translation, so how much you're shifting the graph up or down. And finally, the value of k helps you solve for the period. And the period of the transform function is given by p equal to 360 divided by k. Now, transformations, when you're looking at combinations of the different transformations, you should be able to identify each of the different properties. So the period, the amplitude, the reflection, whether or not it exists, and then the vertical shift up or down, and the phase shift left or right. So here we have a couple of functions, and we're going to try to state each of these. So starting with the period of the function. So the period, remember, it depends on the value of k. So we're going to look to see whether or not there is a k value. And in this case, there is one, and it's already factored out. So to figure out the period of the function here, what I'm going to do is 360 degrees divided by 3. And that gives me the period of the function equal to 120 degrees. And this makes sense because the graph would be horizontally compressed by a factor of 1/3. So the period should be smaller than 360. Okay, in terms of the amplitude, you're just going to look at the coefficient. That's just 6. So A is equal to 6. And in terms of reflection, there is no reflection, so we can ignore that. In terms of a vertical shift, there is no number that's being added or subtracted at the end, so there is no vertical shift. And then there is a phase shift, and it's to the right 360 degrees. So the graph is shifting to the right 360 degrees. Okay, for the second example, the period of the function, if you look at the coefficient here, there is no coefficient, so I know that the period of the function hasn't changed. It's still 360 degrees. In terms of the amplitude, you're going to look at the coefficient of the cosine function, and what you'll notice is that you have a coefficient of -2. Now the amplitude just depends on the height of the graph, and you're looking at half the height. So the amplitude is just going to be +2. Okay, that negative just makes the graph reflect, but half the height of the graph is still 2 units. Okay, reflection, there is one, and it's in the x-axis, so vertical reflection in the x-axis. And then vertical shift is up 2 units since the graph is moving up 2 units. And then phase shift is to the left 180 degrees. Okay, so if you're trying to graph a combination of all of these different transformations, one way to think about how to graph it is to think of part. Okay, so when graphing transformations of trig functions, you want to use part. Calculate the period first. Figure out the amplitude next. So those two will help you set up your horizontal and vertical axes, the scales that you would use for the vertical axis and the horizontal axis. And then think about any reflections. And what this does is help you determine what your max and mins are going to look like. So if the graph has been reflected, then you would switch where your max and mins would be. And then the last thing you want to think about is your translations. So your vertical and your horizontal, your vertical shifts and your phase shifts. Okay, you're going to be graphing 2 graphs. The first graph is just going to incorporate these 3 since it's all things that deal with multiplication. And then the second final graph that you're going to be making will also include the translations as well. Okay, so that would be the solid graph that you'd be making. So let's take a look at graphing combinations of transformations. So to graph combinations of transformations, you will need to first identify the following properties. So figure out the period and figure out the amplitude, and what that will do is help you create the horizontal scale and the vertical scale. And then you can actually sketch 2 different graphs. The first graph is just a rough sketch of what the shape of your function should look like. The second graph will actually take you to where it needs to be based on the vertical shifts up or down. So the first sketch will incorporate only the stretches, compressions, and reflections. So anything that requires some form of multiplication, that's going to be incorporated first. And oftentimes, once you figure out the period and the amplitude and you determine whether or not there's a reflection, it's pretty quick to actually sketch that graph. The final sketch, and this is the one, so this is the one that's going to be dotted, the first one. The final sketch, which is the one that's going to be solid, that one will also incorporate the vertical translation and the phase shifts. Okay, so it will also incorporate the shifts, and that'll be the actual final graph that you want. Okay, so what's going to end up happening is when you make your first sketch, this is actually going to be the graph of y equals a sine kx. It's going to incorporate stretches, reflections, and that's pretty much it, horizontal and vertical. Then the second solid graph that you make will incorporate the phase shift and the vertical shift as well. Okay, same thing if you're looking at cosine, you're going to incorporate all those transformations first, and then you're going to incorporate the phase shift and the vertical shift afterwards. So let's take a look at some examples. So our first example asks us to graph 2 cycles of each of the following, or sorry, this is the last example that we're going to be looking at in this lesson. And it asks us to graph 2 cycles of each of the following. So the first graph I have here is y equals -2 cos of x plus 90. And so the first thing I need to figure out is the period of the function. And what you'll notice is that there's no coefficient in front of the x here, so I know the period of the function will still be 360 degrees. And then we're going to look at the amplitude, and the amplitude of the function is going to be 2. And then the third thing we need to think about is any form of reflection, and the negative here tells me that there is going to be a reflection. So what does that mean? That means that my maximum and minimum values are going to be changing. Okay? Before I start sketching my graph, what I want to also think about is whether or not my axes are set up appropriately. So what you want to think about is if your graph is going to be shifted up, you want to make sure you leave a little bit of extra space at the top part of the y-axis, or same idea if the graph is shifting down. And if your graph is shifting left or right, you also want to leave a little bit of space so that you have enough room to shift the graph the way you need to. So because I will be sketching 2 cycles of this graph, and I know that the period of the function is 360 degrees, I know that one cycle will go up to 360, but the second cycle will go from 360 up until 720. So that's actually the 2 cycles of the graph that I'm going to be making. Okay? Remember, the first cycle will only incorporate this much, and then the second cycle will also include the phase shift to the left 90 degrees. So I'm going to take one cycle and I'm going to split it up into the 5 key points that I need to draw one cycle. And so I'll take this and I'll split it in half. Split it in half again. So I'm going to use a scale of 90s. So I have 90, 180, 270, and then 360. So this will be one cycle of my graph. Now I'm just going to create my marks for the second cycle, but that's all I'm going to do. I don't need to label them. I know that the scale I'm using is 90s. And because this time I have a vertical stretch by a factor of 2, so I need to make sure that my vertical axis goes up to +2 and -2. I don't have to worry about extending it much past that because there's no vertical shift up or down. And now what I'm going to do is I'm actually going to sketch the first cycle of this graph that only incorporates the stretches and reflections. So this is a cosine function. And normally I would start at a max and end at a max, but because there's a reflection, I'm going to start at a min and end at a min. And halfway in between, instead of having a minimum, now I'm going to have a maximum. And so the graph has been reflected because of the negative at the front here. And then between my maxes and mins, I have my zeros. So the first cycle of my graph looks like this. And it's a dotted graph because this is not the one that I'm actually trying to look for. And then the second cycle will look the same. So it starts at a min, ends at a min, has a max in between, and then 0 and 0. And I'll just sketch that really quickly. And there you go. Okay, so now this is almost the graph that I need, except the final graph that I need has a phase shift to the left 90 degrees, which means all my points need to move to the left 90 degrees. And so what I'll do is Luckily, my scale is already going by 90, so I just need to include another mark here where my graph shifts to the left 90 degrees. And so if I'm shifting the graph to the left 90, what I'm going to do first is move all my zeros, because that's the easiest thing to move. And then I'm going to move my maximums, and then I'll move my minimums. So I'm going to move my key points in order so that I don't confuse myself. So shifting to the left 90, shifting to the left 90, shifting left 90, and then shifting left 90. So all my zeros have moved to the left 90 degrees. I'm going to move my maximum, so I'm moving it to the left 90 degrees, moving it to the left 90 degrees, and then finally moving the minimums, so moving to the left 90 degrees, left 90 degrees, and then left 90 degrees again. And if you look at the purple points that I've drawn carefully, it should still follow the same pattern. So all you're doing is you're taking the graph and you're shifting it. So the orange graph that I've drawn has created the shape of the curve, and the purple graph that I'm drawing, the final one, just puts it in the right location. So shifting